So like I said before, example 1A, I honestly, I don't know what I was thinking when I was making this problem, because this, when I graph this, just to plot some points to help us just get a picture of y is equal to 2 to the x here, like that. That's the one function. X is equal to 0. X is equal to 0. That's here. And y is equal to 4. That's up here. Now, there are two options here. First of all, I could essentially change and try and do the rectangles this way. But I realized that when I went through the answers for this, like I could try and do this way, which would make sense, right? But when I solve for this, it's log base, this would be x is equal to log base 2 of y for that function, which would make a lot of sense. I would do the integral from, in our case, it would be 1 up to 4 of log base 2 of y dy. But I forgot that we don't know how to, well, I do, but you guys don't know how to take the integral of a logarithm yet. Not even a natural log. I could, if I changed this to, which would be how to approach it, by the way, natural log of y over the natural log of 2, and then take 1 over the natural log of 2. But you still don't know how to do that. There is a formula for it, but I wouldn't expect you guys to do this on your own. So then that wouldn't be a good option to rewrite this as the log base 2 of y and then go from there. So the only option we would have would be, no, there we go, now it's working, would be to go the other way, because you guys don't know how to take the integral of a logarithm. But the key idea still, it's you need to have a picture. If the picture is not there, a lot of times, it is really helpful to get a picture of what's going on. And I essentially want to find the area in here. So, okay, that means my upper is going to be 4. That's the key, is we want this area in there, not down to the x-axis. So I'm going from 4, that's the upper, to 2 to the x. And then from there, and it's going from 0 to 2. And the way we still have to figure out where it intersects up here. Like, you still have to find that point there to be able to find the upper boundary. So at least there is a little bit of a challenge to this, but kind of not the point here. So sorry about that, but it's still a good problem. So I left it in here instead of changing it. And then going from there, taking the integral and doing the upper and lower boundary. The key is you still, like I said before, you still have to find out that that's a 2. So that the y, when this is 4, 2 to the x, find the x, that would make that a true statement. And then go from there. So substitute in, we end up with something that looks like that, for part A. Part B, however, I did it the right way. So I have y is equal to the arctangent of x. If I do y is equal to arctangent of x, and I'm going from 0 to pi over 4 for here, y is equal to arctangent, looks like this. Don't forget it has an asymptote here of pi over 2. And then it goes down here as well. But we are interested from x is equal to 0. X is equal to 0 happens here, bounded here, and y is equal to pi over 4. That happens here, so pi over 4. So now it's bounded by those 3 things. I'm finding the area in here. Now, I could go from pi over 4 down to arctangent, but we haven't figured out how to take the integral of arctangent yet. We need that comes after the AB exam. But I can go the other way. I can go this way to find. So I have options. So right now, the option of going from the integral from 0 to pi, 0 to whatever, I would have to find the value up there. But I would have to find that point right there. but 0 to something, I could do pi over 4 minus arctangent of x dx, and then find this value up here. So pi over 4 is equal to arc tan of x, and then tan of pi over 4 is equal to x. So tan of pi over 4 is what goes in there, and that's going to be a 1, I think. But I still don't know how to take the integral of that. So you guys wouldn't be able to do this without a calculator. So that's where taking the option and doing it all in terms of y comes in and would be helpful here. So instead, the easiest way for this problem is really rewriting this in terms of y. So that means I just take tangent of both sides. So that would be, whoops, x is equal to the tangent of y, like that. So then I'm going from 0 up to pi over 4 as my boundary. So step number 1, rewrite x is equal to tangent of y. Step number 2, I'm going from 0 to pi over 4 tangent of y dy. So a lot simpler than trying to do it the other way. And then you just integrate in terms of y and substitute in. There you go. So that area there is a 1. For part, I can't letter. So this is part C, and I'm missing part D for the last one. I really messed this up. All right. So in this case, here we have it in terms of y. So that means it's going to look like this. Remember, it's a parabola. This is from your conic sections. It would look, it's facing to the left, like that, and x is equal to -1. That's this line here. So we're finding the area between the curves. So I'm actually interested in this area here. So bounded by that. So for me to be able to do that, I need to find the boundaries here and here. So that I set the two functions equal to each other and solve. And that, you can even see it from the picture, but from -2 to 2. So that means I'm integrating. Upper is g of y. Oops. G of y, and lower is -1. So the upper function is g of y. Here, upper, g of y. And the lower is -1. So here's my lower, minus -1 becomes a +1. And we're bounded from -2 up to 2 for the y values. And then integrate and solve. Like that. That part, the last piece, is easy enough. It's just the setup. I want you to pause the video, try D. It might help you to graph it. The key idea here is that we have, the easiest is to leave this one here in that form just as a conic section here. It's much easier instead of trying to do it the other way around. So if I need both of them, I need to rewrite, I need both of them to be solved for x. So I need to rewrite that second one here in terms of x, and then graph them. And the second one, the blue one here, maybe I'll draw a blue line, is y-intercept is -2, slope is 1/2, so here. Here's the one function. Pretend like I could draw that properly. And then the second one, we have, you know what, maybe it'll help just factoring it. -3x plus, no, y plus 2. So that means the y-intercepts are going to be 3 and -2. So that makes it a little bit easier. And a parabola down this way. Oh, if I could just draw that properly, that would be nice. It's gonna be something like this. I have maybe the points of intersection there. Might be a nice one there. I think it is. Like that. But the key here is that I need to find the area in here. Ooh, that is like heinous. Sorry. It probably comes up a little more like that. So I essentially need to find this area here. It would, if I did it in terms of x, I would have to split it in two. So I would have to then find where they intersect, find this area here, and then find that area in there as two separate integrals. When if I do it in terms of y, I can just do a single integral, which makes it a little easier. So I need to figure out where they intersect here. I see the other intersection. And then by setting the two equal, and they happen to be nice, when y is equal to -2 and 5, it looks like, did I do that right? And here, something is up with my picture. Oh, I, of course, hello, it's facing up. Whoops, that's not what I meant to do. What just happened there? I knew something was up. It's going this way. This way. What did I say? It was 3 there. Hello, something was definitely weird here. It's going that way. That's why. Like that. Not the best picture. Let's just pretend like I could do that properly. And then I see that because -2 and +5 for y, obviously it's going to intersect all the way up there if I could just do it properly, if I could draw it nicely. Oh, that's because I don't, oh boy, I'm really on a roll. It's got to go through there. So, yeah, that makes more sense. So it's this area in here. Whoopsies, sorry. And then once I have the boundaries, it would look like this. Still, though, if I was going to do it with respect to x, again, I don't want to keep erasing it here. I would have to find this area as one integral and then add it to the area here as the other integral. So I still feel like leaving in terms of y is definitely the easiest. If I could just draw it properly. Sorry about that. Whoopsie daisy.